I'm going to explain you the level 7 and how it works, which is the level where instead of pressing buttons, we click on an area on the screen. And that makes the way the algorithm works a bit different than when we have buttons, because buttons are discrete elements, and here we have like an entire map, like it's kind of a geography-based exercise for the machine. So as a reminder, on the left is the actual interface, on top are the emplacement for the 4-digit code. In the middle, the machine is asking us which color is the digit you want to type, and in the button is where I will click to give him feedback. On the right side is what the algorithm is doing, so it's a representation of what's happening behind the scene, and we have the same area that you see here is displayed there. So again, each time I will click on this space to give information to the machine, we'll have the same information displayed for the 10 hypothesis, so the digit from 0 to 9, and we'll see what the machine does with this. And in that case, again, it puts a point of the color that each digit were at the time when I clicked. So again, I'm going to type the code 1, 2, 3, 4, and in that case, I'm going to use the left side of the screen. All this area, in my mind, I will split this area. This is going to be yellow on the left, and on the right, it's going to be gray. So let's start. I'm going to type number 1, so number 1 is gray, so I'm going to click on the right side, anywhere really on the right side. So that's me clicking the first point here. You see on the right, there is the same point in the same location, but for each digit, it has a different color, and the color is the digit, the color of the digit when I clicked. So when I clicked, 0 was yellow. When I clicked, 1 was gray. When I clicked, second was gray. So that's what the machine has in its mind. It's kind of thinking, well, if the user is trying to type a 0, then when he clicked on this location of the screen, it meant yellow. If it's trying to type 1, it meant gray. So let's keep going this. So I'm going to type a 1, which is gray again. So on the right side, left side for yellow. I'm going to do a bit of that until you see something happen on the right, which will be interesting. So number 1 is gray, so on the right. Number 1 is yellow on the left. Number 1 is yellow on the left. So after 6 clicks here, you see that on the right it's very interesting. We see that there is now maps that have been generated for each of the hypotheses from digit 0 and 9. So those are the map that the algorithm, the machine, thinks the user is using if is trying to type the digit 0. So if the user is trying to type the digit 0, then is probably using this area to mean yellow and this area to mean gray. Right? If the user is trying to type an 8, then those clicks, those 3 clicks were gray, those 3 clicks were yellow, and so he's using an area that looks more like this. Now for a 3, it looks like this, and for a 1, which is what we secretly are doing, the machine doesn't know that yet, we have a good separation with left yellow and right is gray. But now it's really hard to know for the machine which one is right there, because number 3 is kind of as valid as number 8 and is as valid as number 1 really. Like both of these are things I could be doing. I could have decided to cut my space, like my map in this way, to put the frontier between gray and yellow in this way. So if you're curious about how the machine generates those maps, you have to look into what's called classifiers in machine learning. And classifiers are these algorithms that are able to draw this line. You see that there is a line drawn between points of different colors, basically. So you have yellow points and red points, and the algorithm is trying to draw a line between the yellow and the gray points, so that next time I click on a place, the algorithm is able to predict if it's going to be yellow or gray. So we'll keep going until we see some evolution of what's happened on the right. So if I type 1, I'm going to click yellow, so I keep clicking on the left. for yellow. I'm going to do that a few more times. So yellow again on the left, yellow again on the left, again yellow on the left. And what you see on the right side now is that the color of each hypothesis has changed a bit. In the beginning, it's more like this orange, pale orange color, where it's kind of, we don't really know, like we don't know if this is likely to be the digit, but when it's really dark red, like this, or number 2 or number 3, that means it's very unlikely that the user is trying to use this configuration. And you see in that case that number 1, the digit we're actually trying to type, is turning a bit towards the green, because you can see that this one compared to the other one is kind of much more nicer. Like all the yellow dots are on the same side, all the gray dots are on the other side. And so it's really easy to write, like to draw that line between the two digits. However, if you take, number 9 is a bit lower in terms of probabilities, but I mean, it's still found a smart way to divide it. It's like, maybe if the user is trying to type a 9, well, then the bottom left corner is yellow, the middle right side is yellow, and an area in the middle is yellow. Well, maybe, I can't fully discard the possibilities that the user is trying to do that. So, so I keep that in mind. But for number 3, for example, or number 2, you see that, well, maybe this is a bit too more intricate. In number 4, I mean, it's unlikely that there is a gray point isolated from view here. And number 5 is really unlikely that, there is like 2 yellow dots in the middle of those gray dots. So let's keep going a bit. So number 1 is now gray. I'm going to click on the right side, yellow on the left side. Now 1 is really high probability. Let's click until we validate number 1. So on the right side for gray, on the left side for yellow. And that's it. So now the algorithm has finally made a decision. So it never can be 100% sure, but he's fairly confident that if the user is being logical, is using the same areas to mean the same thing all the times, then the user is probably trying to type number 1, which is what we were trying to do. And all those points were meant to be yellow, and all those points were meant to be gray, to mean that the color of the digit was gray at the time when I clicked on it. And we can analyze, indeed for 1, I mean, making this line is extremely easy. So you have all the points on the left, or the yellow points on the left, the gray one on the right. However, for number 2, for example, you see that first the map is kind of, it's not a sharp map. Like the yellow is and the gray especially is really light gray. So it's not convinced that this is really what it's trying to do. On the contrary, here the yellow is really, really yellow. So that means in terms of classifiers, that means that this is a very sharp classifier. Like the probability of those points being yellow is really high. And here it's really low. So we discarded all those hypotheses. In the kind of 7, for example, there is a small area of gray here. All the rest really is yellow, but there is this gray click on the yellow area, which doesn't make really a lot of sense. So that's why the algorithm discarded or assigned a lower probability to 7. 0 is quite a nice, banana-shaped area, but again, like there is points that are too close to the other one, so they overlap with the yellow area, so it's less likely than number 1, which is really sharp and really nice. And so again, the machine identified number 1, but as it identified number 1, it also identified that all those points were yellow and all those points were gray, and that's what we're showing there. So when we click continue, what's going to happen is that we're going to propagate the labels, the colors of the number 1 to all the other hypotheses. So now we're going to start typing the number 2 for our code 1, 2, 3, 4. And we already have a lot of information, right? We already know that all those points on the left are yellow and all those points on the right are gray. And so we know, like for each hypothesis, we can start with a lot of information. Each hypothesis starts with knowing that all those points are yellow and all those on the right are gray. And what we're going to do is add information to that. And actually what I'm going to do now is I'm going to refine that boundary, okay? Instead of drawing a straight line here of yellow on the left and gray on the right, actually I want to make an island here of gray and all the rest of yellow. So that's in my mind again, the machine doesn't know that. And I'm going to type a 2. So 2 is gray, so I'm going to click on in my gray island. And you see that this already made quite a lot of changes in the hypothesis space. Why? Because we already have so much information about those points, like we know that all the surrounding points are gray, then it's unlikely that a yellow point, in the case of 6, 5, 7, 8 and 0, that were yellow at the time, it's unlikely that the user is trying to click on this area to mean yellow, because it's really, it's gray, it's meant to be gray. So by clicking there, the user is being inconsistent with respect to the digit 0, 5, 6, 7, and 8. But for all the other one, well, it's a gray point in the middle of a gray area. It's totally fine. So let's keep refining on bordering. Number 2 is yellow, and I want this space, again, all this space to be yellow. So I'm going to click here on the yellow. And I'm going to keep clicking a bit so we can analyze after a bit more information is put in the system. So 2 is yellow, I'm going to click here for yellow, here for gray. So now the machine identified I was trying to type a 2. So let's try to think about what happened. First, on the space, you see that for number 2, indeed, makes sense, like there is a nice gray area, and those yellow are quite distinct from the gray area, and they kind of make this easy to draw line, like a circle around the gray area. So this is easy, like training this line is kind of makes sense. For number 3, however, we have like those extreme points are gray, and in the middle, there is 2 yellow points in the middle of the gray. It doesn't make much sense. For number 4, we have 2 yellow very close to gray, so it doesn't make much sense. Even though the extremes are yellow, those 2 ones are also yellow, so this is unlikely to be a very nice cluster of gray. Same for 9, we have some yellow into the gray, some yellow into the gray, etc. So number 2 is the only place where really it's gray with gray, and even if those yellow are kind of on the right side, you know, in the beginning I told you that I was going to use the right side to mean gray, and the machine actually believed, if you remember well, the machine before did draw a line in the middle that were separating the yellow from the gray. But here, just because of this like hypothesis process, I was not actually using the prediction of that classifier. As well, I was trying to see if the new information was allowing me to train a new classifier that made sense, a new boundary between my yellow and my gray that makes sense. And so even if those points were previously thought to be within gray territory, they are actually yellow. And so that's how the machine identified number 2. It propagated the colors. And now again, if we click, we propagate the colors of number 2 to all of them, so they all have the same hypothesis, like we start again from scratch, and we're gonna try to identify number 3. And I'm going to refine a bit my boundary again. So number 3 is yellow, so I click on yellow. Gray, so I click in the middle of the gray. Gray, click in the middle of the gray. 3 is gray again. And now it identified very easily number 3 in just, I think it's just 4 clicks. So that's really quick. 4 clicks, because you see there is yellow points for most other hypotheses in the middle of the gray. And now we have so much evidence that this area is gray, that if I'm trying to click there to mean yellow, those are discarded really, really rapidly. So again, we're going to propagate the labels to all the hypotheses, because now we are sure that that's what the user is doing. And I'm going to type a 4. And so this is going to be gray. This is going to be gray. This is again a gray. I'm going to put plain center. And gray again. And a yellow, I'm going to put it in that corner. And so you see that, again, we've been able to refine the hypothesis to find number 4. Number 4 is a very nice and easy to draw line between the yellow and the gray, where for all the other one, there is some incongruity. Interesting is 6 is a very interesting case because, you know, all those outliers here could have been yellow. Really, it kind of makes sense, like it's feasible. Like, you know, the machine could have believed that 6 is a good hypothesis, but for this click here on the top left corner, which is gray there, and really this is strong yellow area, as you can see. Like this really, the user never ever clicked on this corner before, so it's assumed to be yellow. So just as a take-home message, you have to remember that that again, like, we are not using buttons here. That means we are using data that are arbitrary. No 2 clicks are ever the same. And that is the first step to using more complex signals. So for example, in the examples you saw on the challenge, like level 5, level 6, you can draw, you can speak to the machine, and the representation of a drawing or a speech is exactly the same as a representation of a click in a 2-dimensional space. Just the sound is just a bigger, the space is just bigger dimensional, but no 2 sounds will be exactly the same, like for our dots. Again, what we saw is that once we find out the first digit, we're not stuck with the boundary. We're not stuck with believing that there is a vertical line between yellow and gray, but actually we can refine that boundary as we get more and more information, as we did in that case. With that, I think you have all the information to solve this level, to code it even yourself if you're really keen on implementing that for yourself. I think it's a very nice challenge and a very nice idea for you to learn about classifiers and about self-calibrating interface, which is what I just shown you here. You can experience this interface for yourself and try to make and challenge the system into doing weird maps that are difficult to differentiate, and try to trick it into failing, basically, like trying to predict a digit that's not the one you are trying to do, and for you to challenge yourself into understanding why the algorithm made that decision by looking at what's happening on the right side of the screen. So you can find the link to this interface below.